On a clear summer morning near Soldotna, Alaska, de Havilland Beaver, registration November 498 to uniform, and a Piper PA-12, registration November 2587, Mike, collided in midair. 7 people were killed, 2 pilots, and 5 passengers. What makes this accident uncomfortable isn't weather, traffic, or bad decision making. Both flights were illegal. Both pilots were doing something completely routine. This didn't happen in a busy terminal area or during a risky maneuver. It happened in uncontrolled airspace, in good visibility, during a normal climb out. If you fly VFR and you've ever felt relaxed because the airspace looked empty, this accident isn't about them, it's about you. Now let's dive in. To understand this accident, you first have to understand the environment it happened in, not just on a chart, but in a pilot's mind. This was Class E and Class G airspace. Uncontrolled, no tower, no requirement for a common traffic advisory frequency, no requirement for position reports. In other words, an airspace structure that many pilots instinctively associate with lower risk. Both aircraft departed legally. Both climbed normally. There was no traffic pattern congestion, no unusual routing, no weather deviation, no sense of urgency. From the cockpit, this likely felt like just another departure into open airspace. And that's an important point, because pilots don't scan the same way when they feel relaxed as they do when they feel threatened. There was no obvious high-risk moment, no pattern entry, no aggressive maneuvering, no weather emergency. This wasn't chaos. This was routine. And routine is where pilots relax assumptions. When the airspace feels empty, when nothing demands immediate attention, the brain shifts into a lower alert mode. Not because the pilot is careless, but because that's how human attention works. We allocate focus based on perceived threat, not actual risk. The NTSB report can show you tracks and altitudes. What it can't show you is that neither pilot had a clear reason at that moment to believe something was about to go wrong. That's the setup, and it's a dangerous one. Now we get to the part of this accident that most pilots have heard about, but far fewer have truly internalized. Constant bearing, decreasing range. On paper, it's simple. In practice, it's deadly. If another aircraft stays in the same place on your windshield, your brain reads it as stationary, not threatening. Human vision is excellent at detecting movement. It's far worse at detecting closure when there's no relative motion across your field of view. If an aircraft is moving directly toward you on a nearly constant heading, it doesn't slide left or right. It doesn't draw attention to itself. It just gets bigger, slowly, quietly. In this collision, both aircraft were flying nearly constant headings. Their speeds were similar. They were at the same altitude. The relative motion between them was extremely low. That geometry creates a visual illusion where nothing appears to be happening until it's too late. This is where see and avoid breaks down in a way that feels deeply uncomfortable to pilots, because it challenges the idea that if it's there, I'll see it. See and avoid fails even when aircraft are visible, not because pilots aren't looking, but because the human visual system is not designed to reliably detect threats that don't move laterally. Casual scanning does not defeat this geometry. In fact, it often reinforces the illusion that everything is fine. This isn't a rare edge case. It's a classic mid-air collision setup. And unless you consciously treat constant bearing targets as threats, your brain will do the opposite by default. That's not a training failure. That's human perception. The NTSB includes visibility studies and line of sight analyses in its report, and they're technically accurate, but they're also abstract. They don't tell you what the cockpit probably looked like in real time. So let's slow this down and rebuild it from the pilot's seat. In the de Havilland Beaver, the pilot was flying a float plane. That matters. The cockpit has thick window framing, and the large radial engine sits high in front of the pilot, especially noticeable during a climb. Forward visibility is not unobstructed, particularly in the exact phase of flight where this aircraft was. Add to that the workload after departure, power management, engine monitoring, navigation, terrain and water awareness. Float plane flying demands attention early, even in good conditions. All of that influences where a pilot's eyes naturally go. It's reasonable to expect the Beaver pilot's scan to be biased forward and slightly to the right, toward terrain and the intended route of flight. Not because of tunnel vision, but because that's where meaningful information usually lives in that moment. Now shift to the Piper PA-12. This is a tail dragger, which means a nose-high attitude during climb. Forward visibility is already compromised by posture alone. On top of that, the PA-12 has structural tubing in the windshield, creating visual interruptions that matter when you're searching for small, low-contrast targets. There's also right-side visual obstruction, and in this case, the other aircraft was appearing near the sun. That's not a minor detail. That's a significant visual challenge. When you put those cockpits together, their structures, their postures, their workloads, and the lighting, the question stops being, why didn't they see each other? And becomes, why would we expect them to? Just because something is technically visible does not mean it is cognitively detected. Detection requires contrast, attention, and expectation. Remove any one of those, and see and avoid becomes fragile. Remove several at once, and it becomes unreliable. And at this point in the flight, both pilots were operating in conditions that quietly eroded all three. The NTSB report mentioned sun glare, but only briefly. That's understandable. Glare is difficult to quantify, and even harder to model. But in real flying, it often matters more than we're comfortable admitting. In this accident, the sun was positioned within roughly 20 degrees of the PA-12's track. That places it in the same sector of sky where the Beaver would have appeared. This isn't just inconvenient lighting, it's a direct degradation of visual performance. Glare doesn't simply make things bright, it reduces contrast. And contrast is what allows the eye to separate an aircraft from its background. A float plane climbing against terrain and water, viewed near the sun, becomes a poor visual target. Not invisible, but weak. Most pilots have experienced this, even if they don't always name it. You spot traffic, look away for a moment, then look back and it's gone. Not because it moved dramatically, but because the contrast wasn't strong enough to reacquire it reliably. If you've ever lost a traffic target in haze or glare, you already know how unforgiving this can be. This is where the discussion naturally becomes uncomfortable, and it's important to slow down. This isn't about judgment. This is about margins. The PA-12 pilot had severe glaucoma. That condition reduces peripheral vision, degrades contrast sensitivity, and increases susceptibility to glare. None of those effects are dramatic on their own. They don't announce themselves in the cockpit, but they quietly shrink the margin that see and avoid depends on. See and avoid assumes fully functional vision. The system has no backup if that assumption fails. This isn't a moral statement, it's a system statement. When we rely on human perception as the primary barrier against collision, we're relying on biology, and biology has limits. In this accident, several small degradations stacked together: lighting, contrast, geometry, workload, visual physiology. None of them were catastrophic alone. Together, they left very little room for recovery. When pilots talk about mid-air collisions today, ADSB often comes up quickly, and that makes sense. It feels like a safety net, but that feeling can be misleading. ADSB out is not traffic protection. ADSB in is not alerting. Unless it's configured to provide unmistakable audible alerts, and unless those alerts are enabled loud enough and timely, ADSB is simply information, and information requires interpretation. In this accident, there's no guarantee alerts were enabled, no guarantee the volume was up, no guarantee the pilot was heads up at the right moment, and no guarantee the system, even if functioning, would have presented the threat in a way that cut through workload and expectation. This is where pilots push back, because we want technology to save us from human limitation. But ADSB without disciplined scan management can actually reduce visual scanning. When pilots believe traffic awareness is being handled elsewhere, attention shifts. Eyes go inside more often. The outside scan becomes intermittent instead of continuous. That's not a failure of discipline. It's a predictable cognitive response. The same illusion shows up with radio communication. It's tempting to say this accident could have been prevented if someone had made a CTAF call, but that oversimplifies the problem. CTAF only works if everyone is using the same mental model. Uncontrolled airspace does not mean uncoordinated airspace, but coordination requires shared expectations. In Alaska especially, flying culture has historically relied heavily on see and avoid, not structured radio choreography. And even here, there was ambiguity. Which frequency? 122.5 or 122.9? That uncertainty alone reduces the effectiveness of radio communication. Radio calls don't prevent collisions. Shared expectations do. Communication is helpful, but it's not a shield. It's an aid, and like all aids, it fails quietly when pilots assume it's doing more than it is. To fully understand this accident, you also have to step back from the cockpit and look at the system around it. The PA-12 involved had experimental modifications. The Beaver was operating in a gray area between Part 91 and Part 135. None of that caused the collision directly, but it matters. This collision wasn't just about two planes on a normal flight path. It's a deeper issue about the fine line between Part 91 and Part 135 operations. Different rules, different equipment expectations, different safety margins. Same airspace, same consequences. One example of that difference is TCAS. TCAS is not required for aircraft of this size, but TCAS is fundamentally different from ADS-B. It doesn't just provide information, it provides commands. It breaks the constant bearing trap by telling pilots exactly when and how to maneuver. If you're in Part 135, you get TCAS. If you're not, you get a collision. That's not criticism, it's reality. And it highlights how much of midair collision avoidance still rests on human perception in environments where perception is fragile. So what should pilots take from this? First, see and avoid is not a system, it's a last line of defense. Treat it like one. Second, constant bearing targets are deadly. If something isn't moving on your windshield, assume it's a threat. Third, sun, angle, and contrast matter as much as visibility. 10 miles of visibility can still be meaningless. Fourth, ADS-B is a tool, not protection. If it doesn't give you an unmistakable alert, it isn't saving you. And finally, fitness to fly is about margins, not legality. Legal does not mean safe for every mission profile. Every pilot in this accident believed they were doing something normal. That's what makes it worth studying. Okay, that's where I'll leave this one. If you fly VFR, especially in uncongested airspace, I'd be interested to hear how you manage, see, and avoid when the margins start to shrink glare, workload, technology, all of it. Thanks for watching, thanks for your support, and I'll see you in the next video. Fly safe.